All right, so I'm going to pick up towards the end of our class discussion, our discussion in class about generics. So we're talking about generic methods, and we talked about um, the selection sort method. And then after that, we started talking about wildcards. But, I realized after class that the examples I made for that topic for wildcards were not that great. Meaning they worked, they compiled, they ran, but they weren't great examples of the use of wildcards. So I made new examples, and I put them here in this file named wildcards.java. So again, this doesn't affect anything before selection sort, including selection sort. All that is good. It's only the stuff these next few methods after selection sort, which weren't great, and you can actually you can ignore the methods below. Okay, so let's talk about wildcards. And I'm going to start by reviewing this this general information that we discussed already in class. So recall that every Java class either explicitly extends another class or implicitly extends the object class. All right, so every class directly inherits from another class or directly inherits from object. And the only exception to that is the object class itself, which neither explicitly nor implicitly extends another class. So the point is, this is really the main point of this first paragraph. Every class, except for object, inherits from the object class, whether directly or indirectly. There is always a relationship between every class inheriting from the object class. Okay. Now, when a class A inherits from class B, we say that A is a subtype of B. We also say that B is a supertype of A. So for example, we had the rational class that we discussed, I believe, in the first day of class. Right, and the rational class the header looks like this: public class rational extends number, and so on. But we see here that the rational class inherits from number; it extends number. And so rational is a subtype of number. Now, here's the thing, though: number extends object. Okay, number extends the object class, and so therefore, rational is also a subtype of object, since number extends object. Okay, now a variable of a supertype can refer to an object of a subtype. And this is an example of polymorphism. So for example, we can say object O equals new rational, whatever. Right, so the idea is O is a variable of a supertype object. So it can therefore refer to an object of a subtype. You can create a rational object, but use a variable of type object to refer to that rational. And it goes even further. So suppose we have a method that takes a parameter of type object, and it does something with it. It doesn't matter what it does. So we can invoke this method. We can call this method by passing it a rational, right? So we can actually we can pass it a rational, and that will work with this parameter object, because it's just like saying object O equals new rational. Okay, however, the reverse is not true. So we cannot say, something like rational R equals new object, right? That doesn't work. And for another example, if we have a method that takes a rational, we can't pass it an object. We can't say we can't just say new object and pass that to this method that expects to receive a rational. And the idea is that not every object is a rational, but every rational is an object. So if I create a rational and I pass it to something that expects an object, that's okay, because every rational is automatically an object, because rational inherits from object. Rational is a subtype of object. Okay, but reverse is not true. All right, now another separate point. So when we have an array or array list or pair or really any sort of container, right? We're thinking of objects that contain other things inside of them, right? So an array contains elements, an array list contains elements, a pair also contains elements in a sense, right? The first item in the pair and the second item in the pair. I'm here referring to the pair class, which we wrote in class, which we looked at in class. So anyways, if we're talking about an array or array list or pair, etc., if it is declared to contain elements of some type, those elements are not really objects. They're not objects, they're just really references of that type, but not objects. And therefore, those elements can refer to objects of their subtypes. So for example, suppose we have an array list of type object, sorry, an array of type object. Object array ARR equals new object of length 10. So we are allowed to say array at index 0 equals new rational 1, 2. Why? Because the elements of this array are not objects of type object. The elements of this array are not even objects at all. The elements of this array are references of type object. And so a reference of type object can refer to a reference of type object can refer to a rational object. Or let's just make this maybe a little more clear like this. Suppose we have suppose it's an array of type number, okay, like this, right? So suppose number array ARR equals new number array of length 10. So each element of the array is not a number object. Instead, each element of the array is a number reference, right? It's like a little reference variable that can refer to various kinds of objects. And in particular, an element of this array can refer to a rational object, okay? Or can also refer to an integer object if I want, right? So I can say, so if I want, I can say something like this. I can say array at index 1 equals, well, I can really just say there's a few ways I can do this. I can say new integer 56, let's say, right? So I'm creating an integer object and using the second element of the array to refer to this new integer object. By the way, this way of creating integer objects is not recommended to be used anymore. The preferred way is now integer.value of. Okay. And actually, we can actually dispense with this entirely. We can just put the int value 56, and Java will perform auto boxing. Meaning Java will automatically wrap this up in an integer object. Okay, so this will work. At any rate, the point is the real point I want to bring out here is that if we have an array of type number, each element of the array can refer to any each element of the array can refer to an object that is any subtype of number. And the same idea is for array list. So here, let's say we had an array list of number list equals new array list. And we can say list.add new rational whatever, right? So the idea is each element of the array is not a number object, but it's a number reference, like a number reference variable. And a number reference variable can refer to a rational object because rational is a subtype of number. And the same idea works for pair. So suppose I have a pair of object, pair equals new pair, and I can say pair.set first new rational, right? So I can, if it's a pair whose elements are of type object, those elements, each of those elements can refer to, say, a rational or some other type of object. Okay, so the idea is every rational, so let's say every rational is a number, right? We could have also said object, but every rational is a number. So an element of an array list of number can refer to a rational, right? So I can say list.add new rational, even though this is an array list of number, it's not an array list of rational, right? It's just an array list of number, but that's okay because every rational is a number. So an element of an array list of number can refer to a rational. can refer to a rational object. It's just like saying, you know, number num equals new rational, right? Which works. Okay, so similarly, let's say we have, oh, this was just the example that I did, right? So well, you know, so number array list of numbers, same idea as before. All right. Okay, so but so okay, I guess I shouldn't have made all these changes before. At any rate, the point is the same. Okay, but here's the thing: it doesn't work in reverse. So suppose we had an array list of rational named list equals new array list. We cannot say list.add new object. Okay, that will not work. Why? The idea is that an object isn't a rational. Right, so when I create an object here, I can't put it into an array list of rational. It would be like saying rational r equals new object. Right? It's like taking a reference of type rational and trying to make that reference variable refer to an object. In other words, refer to an object of type object. But that doesn't work. All right. So now let's ask a question. We've talked about subtypes. We've said, for example, that rational is a subtype of object. So now let's ask, is rational array a subtype of object array? And the answer is yes. So for example, we can say object array ARR equals new rational. Or we can say object array ARR equals, and then we could initialize the elements of the array to be, you know, two different rational numbers. And the idea is that every element of this array is a reference of type object and can therefore refer to a rational. But now let's compare this question with the next question. So we just said that a rational array is a subtype of object array. Now the question is array list of rational a subtype of array list of object? And the answer here is no. And this is something special with regard to generic types. So this is not just unique to array list. This is going to apply to any generic type. So array list is a generic type. You know, pair is a generic type, and we'll see many more generic types over the course of the semester. You may know of some other generic types yourself. If you're familiar with, you know, maps or sets in Java, then you know about other generic types. But at any rate, this is going to apply to all generic types. But we're taking array list as an example here, and we're saying that an array list of rational is not a subtype of array list of object. And so what is one important implication of this? So for example, if we have a method that takes an array list of object, we cannot invoke it by sending it an array list of rational. All right, so suppose we have an array list of rational, you might say, oh, great, this array list of object, this is an array list of object, and we know that rational is a subtype of object. So shouldn't I be able to pass an array list of rational into this method that expects an array list of object? So the answer is no, we can't do that. So why does Java prevent us from doing that? So there are a few ways this can be explained. I'm not sure what I'm about to say is the best explanation, but it is a explanation. It is an explanation. So here's my explanation. So suppose Java would let us do this, right? So suppose we could have a method that takes an array list of object, and we would be able to pass it an array list of rational. So here's what might happen. So this is a perfectly legal method, right? It takes an array list of object, okay, and then it goes list.add. It goes to index. It adds at index 0 a new object. Okay, it creates a new object. And then suppose we call this method as follows. We create an array list of rational. Array list rational list equals new array list. So when we're creating an array list of rational, we are saying that we only allow rational elements into this array list, or anything that's a subtype of rational, right? But we don't allow other things. We don't allow strings into this array list, and we don't allow number, or we don't allow integers into this array list. We don't allow object. We don't allow things of type object into this array list. We only allow things of type rational or any of its subclasses. Right, so that's what we mean when we create an array list of when we create an array list of rational. And so, well, let's see what happens if we take this array list, right, and pass it to our method. Okay, and so of course we know that Java is going to prevent this from happening, but let's imagine that Java would not prevent this, right? So let's suppose that this would be allowed, and then we would go ahead and say rational. So we would go ahead and send it to the method, and then once we come back for the method, we would say rational r equals list.getZero, right? So we would get the element at index 0 out of the list and store it in rational r. So the code will compile fine, but this line here, when we run the program, this line would generate a class cast exception. And the reason for that is that a rational reference variable cannot refer to an object of type object. In other words, list.getZero refers to an object of type object. We created a new object. And so we cannot use rational r to refer to that. If we try to do that, we'll get a class cast exception. So to avoid falling into such issues, Java doesn't allow us to do this kind of thing at all. In other words, it doesn't let us take an array list of rational and send it to an array list of object and send it to a method that takes an array list of object. The way Java does this is it says array list of rational is not considered a subtype of array list of object, right? And but this is just an example with array list and rational, but this would apply to any generic type. Okay, I'm just realizing I can maximize the screen here, so that's pretty nice. Okay, now more generally, even if A is a subtype of B, an array list of A is not considered a subtype of array list of B. So another example, let's say you have a pair of A. Let's say A is a subtype of B, but nevertheless, a pair of A is not considered a subtype of pair of B. Here's another way to understand why an array list of A is not considered a subtype of array list of B. Okay, so I gave one explanation here with this method example, but here's another maybe more intuitive way, maybe not, but it's just another way of explaining it. So what does it mean when we say A is a subtype of B? So like, for example, what does it mean when we say rational is a subtype of number? Well, what that means is that A has at least whatever B has and possibly more, right? But so rational is a subtype of number. Why is rational a subtype of number? Because it has all the capabilities that number has. It has at least all those capabilities. Maybe it has some more capabilities, but it has to have at least all the capabilities that the supertype has, right? So, or for example, rational is a subtype of object. Why? Why do we consider rational a subtype of object? Because a rational can do at least whatever an object can do, right? It can call the toString method, it can call the equals method. All those things that an object can do, a rational can also do. And actually, a rational can do more things, but that's not the main point. That's not the main point. The point here is that a rational can do at least whatever an object can do. Okay, but let's say we would want to consider, let's say we would want to consider an array list of rational to be a subtype of array list of object. Here's the problem we would have with that. What type of things can we add to array list of object? Well, we can add things of type object to such an array list. We can also add things of type rational to this array list, right? But if we have an array list of rational, we can add things of type rational to this array list, but we cannot add things of type object to this array list, right? So while we can add rationals and objects to an array list of object, we can only add rationals to an array list of rational, right? So we cannot add objects to it, right? So the idea is that it's not correct to say that array list of rational is a subtype of array list of object, because we see that an array list of rational doesn't even have all the capabilities that an array list of object has. All right. Now let's get into these using wildcards. Okay, so let's say we have a method like this. All right, so this method takes an array list of object and it generates a random index in this list and it prints out the element at that index. Now, let's try to call this method. All right, so suppose we have an array list of object list equals new array list. And then here's how we can quickly initialize the elements. We can say list.of, and we can put in elements here. Now we can put in new object. We can also put in, strings like cat. We can also put in like integers like 34 because string inherits from object and the integer class inherits from object. So Java will autobox the 34 into an integer object so that all works. And now we want to go ahead and print a random element of the object list. So we'll call print random object and send it the object list, and it will work. Okay, so we can go ahead and try it. We're compiling first. And okay, so we started by printing out the object list. So we got this list of objects, and then we got a random element, and it's cat. Okay. Now, which is this middle element here. Now, suppose we have something like this. So suppose we have, where are we? Okay, so suppose we have a string. Sorry, suppose we have an array list. String, call it the string list. Equals new array list. And we can put in some strings. Oops, sorry, I forgot to do list.of. Okay, list.of. And then we can put in some strings. All right. And suppose we want to now take our string list and send it to the print random object method. So we want to print a random element of our string list. We see here, ID tells us there's the compiler error here, this red line. And the message says the method print random object array list of object is not applicable for the arguments array list of strings. What does this mean? Well, the parameter of the method is here's the method header. Actually, I copied it here. The parameter is array list of object. So I cannot pass to that array list of string, even though string inherits from object. Okay, so this won't compile since array list of string is not a subtype of array list of object. So the thing is, we would like to have, sorry, this is a mistake. Hold on. So we would like to have a method that will take an array list of any type and print a random element of it. So here's one way to do it, right? So we can say array list of an unknown type. So the question mark means unknown. So an array list of unknown type list. And we just want to print a random element. So the idea is exactly as before. We get a random index and we print it out. And we print out the element at that index. By the way, just a little point. Here I'm using something called a random generator. Okay, so I can actually do this on two separate lines. So what I can really do is say, let me say this. I'll say random generator. Let's call it, I don't know, generator equals random generator dot get default, and then I can say generator dot next int. Okay, so it works similar to the random class if you're familiar with it. But this is a newer way to generate random things in Java. Okay. Now, so again, okay, fine. So we have an array list. We have a method that takes an array list of an unknown type. Right. So this question mark is called a wildcard. Here we're actually using one of the types of wildcards, which is called an unbounded wildcard. Okay, so we didn't put any restrictions on this wildcard. It's unbounded, no restrictions. But what does it mean? Array list of question mark means an array list of unknown element type. Now we can actually write this method header without using question mark at all, without using wildcard. So let's, before we do that, let's show how we can call this method. Right, so we have this method with the header public static void print random element array list of question mark list. And so we can go ahead now and say print random element of the object list, and it will work. And then we can create an array list of strings, string list equals new array list and containing some strings. And then we can print a random element of the string list by calling print random element and passing the string list. Right, so the idea is that now this print random element method that we just saw works for an array list of any type, right? An array list of string, array list of object, and it would also work for array list of integer, it would work for array list of rational, and so on and so on. Okay, now we can actually this method is very nice, but we can actually write the method if we wanted to. We could write it without using wildcard at all. All right, so this method header of this method that we just saw can actually be written a different way. This method header actually works just like this: public static, and then e defining a generic parameter, void print random element array list of e list. Okay, so so again, it's an array list of some type e, and we defined e here in the method header as being some type which can be anything. So as we said, this line here, this method header works just as well as this. So what's the benefit of using wildcards instead of doing this? I mean, after all, we first saw how to do this. So why would we now want to use wildcard? So it makes our code a little bit simpler and perhaps a little bit easier to understand. So what I mean is we can use an unbounded wildcard instead of e here, since we have no need to use the generic type inside the method. I'm sorry, this word generic type is not that phrase is not correct. Let me rephrase that. All right, so what e is, the technical term for what e here is in this header here is a formal type parameter. Okay, so what do I mean by type parameter? Well, it's a parameter, but whereas usually a parameter is a piece of data, right, like an integer or a string, here the parameter is a type, right? So it's a type parameter. It's indicating that there's some type that can be passed into this method. Now, my point I'm trying to make here is that this particular method, print random element, has no need to define a formal type parameter e, because we don't use e anywhere inside the method, right? We don't use e in the method, nor do we use it as a return type of the method. So there's really no need to have to define a formal type parameter e for this method, and we can just use instead a wildcard. If we compare this with some of our generic methods, right, which we saw in the in class, right? So for example, here we had a swap method, right? So you might say, well, let's do the same thing here. Why do we have to use a generic? Why do we have to use a? Why do we have to? Sorry, why do we have to define a formal type parameter e? Why don't we just use array list of unknown type, and we'll get rid of this in the method header, and that'll be it. That'll be good. See, the problem here is, what is e, right? We need to use e here to get the temp, or we want to get the temp before we do the swap. In order to help us do the swap, we want to use a temp. But what is the type of temp? It's going to be of type E. But what is E? We have to specify that in the method header that we're defining a formal type parameter named E, which is the type of elements that are in the list. Right, so for this swap method, since we need to use E inside the method, it would not be appropriate to use wildcard. Okay, so but again, this print random element method, there's no need for using E inside the method, nor as a return type of the method, and so we can just use wildcard. Okay, good. Now let's talk about two other ways of using wildcard. So we saw how to use a wildcard as an unbounded wildcard, but now let's see how to use it as a bounded wildcard. So there are two ways to use it as a bounded wildcard. So suppose we have a method like this, public static void do something one, it takes an array list of question mark extends number list. So what does this mean? It means this can be an array list of number, or it can be an array list of any type that extends number, that inherits from number in some way. So the upper bounded wildcard question mark extends foo, where foo is any type, matches foo and any subtype of foo, right? So it can be an array list of number, or it can be an array list of integer, or it can be an array list of rational, anything that is a subtype of number. So we can pass to this method an array list of number, or an array list of rational, or an array list of integer, etc. But we cannot pass to this method an array list of object, because object is not a subtype of number. Nor can we pass to this method an array list of string, because string is not a subtype of number. Okay, now why would we ever want to do something like this? Well, here is a method, and I'm actually going to first write it in a different way. So let's say we have a method like this. Public static double sum. It takes an array list of number, and it's supposed to find the sum of the elements in the list, and it's supposed to return the sum as a double. All right, so how do we do this? We do double sum equals 0, and we do for number in list, we do sum plus equals number dot double value, and we return the sum. Now, why do we have this? Why do we specify this as an array list of number? Why don't we just say array list of object, or you know, why array list of number? Well, the thing is, I want to be able to call the double value method on each element of the list, right? Because what are we adding to the sum? Well, we're adding to the sum the element that's in the array list, but we can't add that element directly to the sum. We have to first get its value as a double. So we take the element of the array list, we get its value as a double, and then we can add it to the sum. But how can we be sure that there is a method called double value that returns that returns the value of the element as a double? The only way we can be sure of that is if the elements of the array inherit from the number class, because the number class provides a double value method. Right? If we go ahead and we just take a look for a second, right? So if I just search for Java number 17, 17 being one of the latest versions of Java. So we see here the class number, and if we go to the methods, we see there's this double value method in the number class, and it returns the value of the specified number as a double. All right, so that's why we have this as an array list of number. But now let's try to go ahead and go in main and try to call this method. All right, so suppose in main, we go ahead and create an array list of, sorry, hold on. Suppose we go ahead and we say array list of number. Oh, let's call it number list equals new array list. Let's say list.of, and we'll put in, let's say 56 and 7.8. All right, so that's our array list of number. And now suppose I want to find the sum of the elements of this array list. So we can say say sum of number list. Right, so this works just fine. We have an array list of number, and we can pass it to the sum method. Right, the sum method takes an array list of number. The problem is, suppose we have an array list of integer. named integer list containing some integers. And we want to find the sum of the elements in this list. So you might think, oh, let's just send it to the sum method. The sum method will go through the list. It will add up each element together, add up the elements together to get the sum, and it will work. The problem is that the header of the method, as we see here, is array list. Well, so far it's just array list of number, right? The problem is that we cannot send an array list of integer into a method that expects an array list of number, even though integer inherits from number, right? But because of the way generics work in Java, array list of integer is not considered a subtype of array list of number. Okay, so what are we going to do about that? So one idea you might think is to do this. Let's just say an array list of some unknown type, right? So an array list of some unknown type, and now we should be able to pass anything to this method, right? We should be able to now pass, and in fact, all the error messages went away, right? So we can pass an array list of integer to this method because this method, the sum method, takes an array list of any type, right? An unknown type, but it could be anything. So it could be an array list of integer, it could be an array list of number, all that will be fine. But now we have a problem in the sum method itself. So how can we say number.double value, right? How can we take each element of the array? First of all, how can we say each element of the array is a number? But furthermore, how can we say that each element of the array has a double value method? If it's an array list of containing unknown type of elements, then these elements of the might be strings for all we know, and there's no double value method in the string class. So this is not enough, right? It's not enough to have an unknown type to use a wildcard, but rather we have to put a restriction on the wildcard. We have to say it's an array list of an unknown type that has to extend the number class. Okay, and so now we're saying that this could be an array list of number, or it can be an array list of integer, or it can be an array list of rational. Regardless, there's going to be a double value method which we can call, and we can get the sum. Right. So now if we go back to main, so this original array list, which is a number list, array list of number, that the sum works. If we have an array list of integer, integer list, we can also find the sum of that. If we have an array list of rational, we can find the sum of that. But if we would have an array list of string, we would not be able to pass it to the sum method, right? Java would, the compiler would prevent us. All right, so that's an example of using an upper bounded wildcard. Idea is we put an upper bound on this unknown type, right, on the wildcard. In other words, it can be anything that is number or below, an array list of number or anything below that, but not above. So we put an upper bound. So that was the sum example. Now the third and final way to use wildcards is to use them as a lower bounded wildcard, right? So suppose we have a method public static void do something to, takes an array list of question mark super number list. So what does that mean? So this is a lower bounded wildcard, question mark super foo, where foo is any type, but so this wildcard matches foo and any super type of foo. So in this particular case, question mark super number, we can pass to this method an array list of number or array list of object, because object is a super type of number. But we cannot pass to this method an array list of rational, nor can we pass an array list of integer, nor can we pass an array list of string, etc. Right? Because all of those are not number and not super type of number either. Okay, now what would be an application where we would want to use where we would want to use a wildcard with super? In other words, use a lower bounded wildcard. By the way, again, this is a lower bounded wildcard because we're putting a lower bound. We're saying it could be number or anything above it, any super type of it. So we're putting a lower bound. Okay, so here's an example of a method where I would want to use a lower bounded wildcard. So it's a very stupid method, and it's actually surprisingly hard to come up, at least for me, to come up with like uh, practical examples where you would use super, but it does come up. And we will see examples like where we're going to use methods in the Java API, right? Methods that are built into Java. And we're going to see that they use, things like question mark, super, whatever, question mark extends, whatever. So, but these are, this particular example that I'm showing you right now is not a not a very not a very not a very interesting example. Anyways, this method takes a list and adds a random rational number at the head of the list. So it takes an array list and it generates a a random rational number. How does it do that? Well, it says rational r equals new rational, and it says generator.next int for the numerator and generator.next int for the denominator. So it generates random integers, and then it takes this rational number that's a random rational number, and it adds it into the list at index 0, meaning it adds a random rational at the head of the list. All right, so now suppose we would just suppose we wouldn't use question mark super rational, right? We would just have it like this, right? So what would be the issue here? Well, the issue would be if we go here to main, suppose we have an array list of object, named list equals new array list. Okay, and it could even start out as being empty. And what we want to do is pass this list to our new method that we just saw. And we want this method to add a random rational number at the head of this list. Okay, seems like it should work, but here's the problem. Let's try to compile it. Let's see if there is a problem. All right, so we get an error on line 210 in the add random rational at head method inside this method. Now, the the message here is well, not very understandable, but basically what's going on here is that if we don't know what type of thing this is a list of, the compiler is not sure that we can actually add a rational to this list. Because, for example, if this would be an array list of string, it wouldn't make sense to be able to add a rational number to an array list of strings, right? So we want, but so the problem is we want to have we want this method to work, obviously. So one idea would be to say, oh, let's only be able to take an array list of rationals, right? So if we specify that this parameter is specifically an array list of rational, then Java will have no problem adding a rational number into the list, because if I have an array list of rational, then I can obviously add a rational to the list, and that's true. But here's the different problem now. We go to main, we try to call the method, right? So here we have an array list of object, and we want to call the add random rational at head method. We want to add a rational to our array list. Now, or even suppose if we have array list of number, right? So here we have an array list of number, list equals new array list, and we want to add random rational at head. Okay, now you might think it should work, right? It should work because logically it should work because every rational inherits from number. So if I have an array list of number, right? If I wanted to, I could say list.add new rational, let's say 1, 2, and that would certainly work, right? This would certainly work to say list.add new rational, even though it's an array list of number, not an array list of rational, or even if this would be an array list of object, right? It would be legal to say list.add new rational 1, 2. But now I'm trying to call my method here, And right now, the way we have the method is it's just takes an array list of rational. This is not going to work. So let's try to compile. Okay, here we have an error on line 150 right here. Incompatible types, array list of object cannot be converted to array list of rational, right? So the problem here is that at the moment, the array list is an array list of, sorry, the parameter is array list of rational. And so I cannot pass an array list of object into this method. Okay, so, but we want this to work, right? We want these lines to work here because logically it makes sense that if I have an array list of objects, just like I can say list.add new rational, I should be able to pass this list to the method, and that method should be able to add a new rational to the list. So how can we fix this method? So we can do it by using a bounded a wildcard with super. Okay, and let's just go to the method here. Okay, so here we're saying question mark super rational. So this means it's an array list of any type that is either rational or a super type of rational. So I can pass in an array list of rational, or I can pass in an array list of number, or I can pass in an array list of object, right? So let's just write this in. We can pass to this method an array list of rational or an array list of number or an array list of object, right? But we cannot, but not an array list of, let's say, integer, okay? And that makes sense because if I have an array list of integer, then it does not seem reasonable to add a rational number, because when I have an array list of integer, I'm saying I'm only having whole numbers, integers in this list. But a rational number might not be an integer, right? So that makes sense. So we also, if we have an array list, let's say array list of string, that also won't work, right? But if I have an array list of rational or an array list of number or an array list of object, those are all good. I should be able to create a rational and put it into the list. And so now if I go back and recompile, fingers crossed, yes, it works. Okay, good. Okay, so I think we covered this topic of wildcards a little bit, and now let me go back to the pair class. And I want to quickly review some things here and then actually show some new things in the pair class as well. All right, so okay, so let's start from the beginning. We have a public class, it's a generic type, pair of T. Okay, this is a generic type, meaning pair is a type that has a generic aspect to it. And in other words, when we create a pair, we specify, hey, this is a pair that contains a certain type of object, a certain type of thing, a certain type of data. Okay, and we can put anything we want here instead of T. We don't actually have to use T. We just have to be consistent. Whatever name, whatever identifier we put here, right? So we can put our type, whatever. If we do that, we just have to, wherever we see a T, we have to replace it with our type, right? So this is all, we'd have to do that. And that's all fine. Just my point is, you don't have to use T. You don't even have to use a single letter. Right? You can use a word, okay, or a few words. Well, one identifier. At any rate, so what does a pair have? A pair has a first and a second, both of type T. Now, when we have this formal type parameter T here, right? So this thing is defining a formal type parameter named T. We can use T throughout the class, but only in instance situations, not static situations. What do I mean by that? So the first and second are instance variables. right? Or you can say they're instance fields, meaning each instance of the class, each object of the class gets its own copy of first and its own copy of second. And so you can use T with regard to instance fields. You can also use T with regard to instance methods and constructors. Okay, so constructors are similar to instance methods, and if you have an instance method like this, you can use T inside the method. However, if you have a static field or a static method, T does not apply there. Okay, T is only applicable in instance contexts, not static contexts. So we'll see an effect of this shortly. I don't know why this is doing strange stuff here, but go ask Replit. Anyways, let's take a look now. Okay, so we have a constructor that takes something of type T and another thing of type T, and it assigns each of them to the appropriate fields. Now we can also have a copy constructor. So what does the copy constructor do? It takes a pair of T, an original pair, and it's going to initialize the new pair to be a copy of the original pair. So it's going to say this dot first, meaning the first field, right? This field, the first field of this current new object that we're creating should be assigned original dot first, and this dot second should be assigned original dot second. Okay, this copy constructor provides one way of making a copy of a pair. Another way to make a copy of a pair is to use this clone method. So this is an instance method. It's an instance method, right? And you can call it by taking, if you have a pair object, you can use it to call this clone method. And what this clone method does is it takes this dot first and this dot second, it uses them to create a new pair. So it calls the constructor, says new pair, this dot first, this dot second, and it returns a pair of T. And then set first is a simple method. It takes something of type T and it uses it to set the first field. Set second, same idea. Get first, it returns something of type T. Again, here we're still using this formal type parameter that we defined as part of the pair class. And these are all instance methods, so this is all good. And get second, same idea. ToString. So what does ToString do? It returns a string containing an open parenthesis, and then the first, and then a comma, and then the second, and then a closing parenthesis. Now, how about the equals method? Right, so we saw this before, but previously, so let's actually start here. So public boolean equals object O. The first thing we check to see is O instance of pair. Now, previously, the way I showed this was I just had it like this, right? I said, if O instance of pair, pair other equals pair O. So you might think, oh, I should say if O instance of pair of T, right? That might be a logical thing to do. However, this would not compile. This has to do with some of the technical details of how generics work in Java that I really don't want to get into. So you cannot, when you're using instance of, or you're using casting, oh, I'm sorry, take that back. When you're using instance of, you cannot say pair of T. Okay, so what could you do? So one thing is you can just leave it like this. If O instance of pair, and then you can say pair other equals pair O. That's all fine. And this actually will work, even though you're not putting angle brackets after the word pair. It actually, the dirty secret is that pair can actually work without angle brackets, right? So even if I want to, I could go ahead, even in the main method, let's say, and say pair bad equals new pair, and let's say put in, I don't know, let's say very bad. Okay, this will work and will compile and will work, but this is not a recommended way to use generic types. This is technically what we're the term for this is we're using pair as a raw type here, right? We're using it as a raw type without specifying those angle brackets, and it's legal, but it very often leads to bugs, and so we try to avoid it. Okay, so, but sometimes in rare cases it might be necessary. So one case I initially thought that it might be necessary was here, right? So I cannot say pair of T, so I thought, oh, let me just say if O instance of pair. However, actually we can use unbounded wildcard. Okay, if O instance of pair of any type, then we'll have pair of unknown equals pair. We'll take O and cast it to pair of some unknown type. So now we have this and we have other, and we need to compare, are they equal? So how do we tell if two pairs are equal? Well, return this dot first that equals other dot first, and return this dot second that equals other dot second. If both those things are true, then we return true. If either of those is false, we return false. Now, what about if O is not an instance of pair of some unknown type, right? In other words, what if O is not an instance of pair at all? Then we'll just return false. Okay, so that's the equals method. Now, here we have an example of a static method. Okay, so what is the static method all about? Well, so sometimes you might want to create a pair without explicitly calling the constructor. So what do I mean by that? Well, here's an example. I think I have an example here. No, I guess not. So let me make an example. Oh, here's an example. Okay, good. Here already an example. So I can say pair of string equals another string. Sorry, pair of string, another string pair equals. And so one way to do this would be to say equals new pair, blah blah blah. But another way to do it is to call this method that I'm about to show you. The name of the method is of. That's the name of the method. And this is actually a pretty common method. If you look around in the Java API, you'll see this method name come up in a lot of places, and we actually have seen it already ourselves. Remember, we pretty recently we talked about like list.of. We use list.of. Remember list.of, like list.of. Okay, so here this is a static method named of in the list interface. Anyways, the typical way the of method works is that it takes inputs and it calls like, and the method goes ahead and calls the constructor and returns you the new object. So in this case, I want to have a method in the pair class, a static method named of, that takes two inputs and returns a new pair, right? So it just gives us another way of creating a pair object without having to explicitly call the constructor. So how can we write this of method? All right. So here it is. So it's a static method, public static. Now, remember I said that the formal type parameter t that we defined for the pair class only applies to instance contexts. So it applies to instance fields or applies to instance methods. It can only be used in those contexts. But in a static method, it cannot be used. And so if I would just if I would leave this out here, right, let's say I would just do this. I would try to just say public static pair of t and t first, t second, right? So again, this is a method that takes something of type t, the first thing and a second thing, and it calls the constructor, return new pair first and second, and the return type is pair of t, right? So that's the idea. You give it things of type t, and it goes ahead and calls the constructor. It sends those two things to the constructor, and it returns a new pair of that type. All right, so this looks like it should work, but when we try to compile this, let's see what happens. Oops. Okay, Java C pair.java. All right, so we get 3 errors, but they're all, I think, of the same source, of the same reason. Non-static type variable t cannot be referenced from a static context. Right, so this t, which is only non-static, can only be used in a non-static way, cannot be used in a static method. So what do we have to do here? Well, we have to define a new type parameter, a new formal type parameter specifically for this method. Okay, so we cannot rely on t that was defined as as a class-wide formal type parameter because t is not because that is only for instance situations. So what are we going to do? We'll define a new type parameter. Let's say we can call it u, okay, and we'll say, and then the return type will be pair of u, and the parameters will be u and u. Okay, we can use any name we want, but I'll just use u. So again, so it takes two things of some type u, which is defined to be some any type that, you know, it's just a generic type parameter, so it could be anything, and it takes two things of that type and it sends them to the constructor, and it returns a pair of u. Okay, now here's the thing. Actually, we can, if we want to, instead of u, replace all the u's with t's. Okay, now we're still not really using the formal type parameter that was defined for the pair class. Okay, even though we're using the something called t, it's really a separate thing called t. It's a special t specific for this method. It's like a new type of t. But that seems very confusing, right? Because if I'm using something named t, it looks, I mean, it's the same name as the one we use for the class-wide thing. So many people prefer, instead of using t here, to just do something like u, right? So, but that's kind of up to you. The main point here is that we have, since this is a static method, if we want to use a generic type, if we want to have some generic thing in this method, we need to define a formal type parameter for this method, and we cannot rely on the one that was defined for the class. All right, so that's this of method, and it works, I believe. Let's just make sure. Well, at least it compiles. Okay, so that's good, and I believe it works as well. I say, let's see. So here I have the main method, where I create at the very end pair of string, another string pair dot of hello world, and we print out another string pair. So let's go ahead and run this. Okay, the last line of output is hello world as a pair, and that looks good. Okay, now let's write two more methods in this pair class. So here is an interesting method, public void. So it's not a static method. It's an instance method. And the goal of this method is copies the values from the other pair into this pair. Okay. So it takes as the parameter, it takes another pair, and it copies the values from the other pair into this pair, right? So in other words, it says, let me just actually simplify this a little bit. I'll just say this dot first equals is going to be assigned other dot first, okay, and this dot second is going to be assigned other dot second, right? In other words, it's going to copy the values from this other pair into this pair. Now, here we are using a bounded wildcard question mark extends t. Why? Why don't we just say copy from pair of t other? Right? That would seem like a more straightforward way to do this. In other words, you have a pair of t, and you're going to copy from that other pair. Well, here's the issue. Here we have we have two pairs of interest right here. We have an integer pair, okay? Pair of integer pair equals new pair of integer. Okay, so whatever. It's this. By the way, this is actually optional here. We could leave it out. So we have a pair of integer, and it contains these two items, and then here we have a pair of number pair equals whatever. Okay, now what we want to do is, I think copy from comes first. Right, so we're working on the copy from method. And what we want to do is we want to call this copy from method. So we want to say number pair dot copy from rational pair. Oh, I'm sorry. I don't know why I mentioned integer pair. Okay, I meant to say here we have a pair of rational pair. Okay, so fine, it's a pair of rational, and here we have a number pair, pair of number. And what I want to do is number pair dot copy from rational pair. In other words, I want to copy the things from the rational pair and put them into the number pair. Okay, and that seems like it should be a very reasonable thing to do, right? A rational pair contains rational numbers, and every rational number, inherits from the number class. So if I have a number pair, it should be able to contain rational numbers. So I should be able to copy from rational pair and put them into number pair. At least that's what it seems like I should be able to do. But let's try to compile this. Okay. And let's see what happens. And here we have an issue. What's the issue? So the issue is how we wrote the header of the method. So we wrote copy from pair of t other. Well, here's the problem. What is pair of t? And sorry, what type is t? Right. So what I'm trying to say, when I say number pair dot copy from rational pair, here t equals number. Why? Because we're using a pair of number to call this method. We're calling the method by using a pair of number. And so if I try to send in a pair of rational as the parameter, it doesn't match, right? So a pair of rational cannot be converted to pair of number. So how do we fix this? Okay, so we already probably know how to fix this, right? So we say this is a pair of any type that extends t. In other words, if t is, let's say, number, I should be able to pass in a pair of rational, because rational extends number, right? So I should be able to pass in a pair of rational. I should be able to pass in a pair of integer, right? So that's all good. Okay, now let's just make sure this compiles. And let's see that it runs without throwing an exception. Okay, and it does. All right, so that's the copy from, and that's another example of using a bounded wildcard. Now let's look at this next method, copy to. Okay, so let's say we have this. This very similar idea to the previous method. Sorry about this thing that keeps popping up. I don't know why it's doing that. It's probably very annoying for you watching, just like it's annoying for me. Sorry. So anyways, here the goal of this copy to method is as follows. It copies the values from this pair to the other pair. Okay. It copies from this pair into the other pair. So in other words, we call this method by calling it on a specific pair. So really, actually, let me simplify this. I will simply say other dot first is going to be assigned this dot first. Right? Notice it's like the exact opposite of the previous method, right? It's other dot first equals this dot first, and other dot second is going to be assigned this dot second. Okay, so that's all very nice, but what's the problem? Well, the problem here is similar to before, right? So let's say we have an integer pair, so a pair of integers. So what is t here, right? Here, t equals integer. And so the problem is I am not able to pass in a number pair, a pair of number into the copy to method, because right now the parameter is pair of t. And on this line right here, t equals integer. So how can I pass in a pair of number? But really, I want to be able to pass in a pair of number, because it makes sense that if I have integers in this pair, I should be able to copy them and put them into a number pair. So what am I going to do with this, about this? So the solution is, as we saw, to use pair of question mark super t. So now I can pass in a pair of any type that is a pair of t. I can pass in a pair of t or pass in a pair of any type that is a super type of t, right? So for example, if I here again t is integer, right? I have integer pair and I'm using integer pair to call the method. So t is integer is equal to integer, but I can pass in a number pair because number, right? Number is a super type of integer. So this is a pair of number and that's good. Okay, and so this is all works out well. Now it seems very confusing. When do you use extends? When do you use question mark extends, and when do you use question mark super? Okay, so there's a very nice mnemonic. Okay, mnemonic is the silent M, so it's pronounced mnemonic, and a mnemonic is a memorization tool, and it is PEX. Okay, I could show. I don't know. But anyways, I'll show you where this mnemonic comes from in a second. But what it stands for is producer extends and consumer super. And here's the idea: anytime you have a generic type that is producing things, that's where it's appropriate to use extends. I shouldn't say anytime. Very often, when you have a generic type that is producing things, you use extends. When it is consuming things, you use super. So let's compare these two previous methods. So this method, we are copying from this other pair. So in this case, other is a source, right? In fact, I could even rename it if you want, source. Yes. Right. So in other words, this parameter is a source. In other words, it's a producer of elements. We're producing things from here, and we're putting them somewhere else. But the point is, this thing is a producer, and so we use extends. Right? Producer extends. This other method, we're copying to other. In fact, I can even rename this to destination. Okay, destination. Right? So we're copying into this thing. So in other words, this pair, this destination is a consumer of data. It's a consumer of elements. It's taking things and consuming them. And in other words, we're putting them into the destination. And so consumer, we use super. Okay, where does this mnemonic come from? It comes from this very, very, very good book called Effective Java by Joshua Block. The latest edition, I believe, is the third edition. If you really want to know Java very, very well, this is the book to get. It is not an easy book to read. It is not a textbook. It is not it's not written, it's not a beginner friendly book. But if you want to really, really know Java well, how to use Java in the most effective way, this is the book to get. Notice, by the way, this book will not help you with things for this course. It's not going to be relevant to things. It won't teach you data structures. It will teach you Java specific things. But it's a very good book, and this book has many chapters on generics, and this mnemonic comes from that book. Okay, you can also, if you look up this guy on YouTube, Joshua Block, he has a lot of talks on YouTube about Java. Very, very interesting. All right, so here I believe we've talked about this pair class enough. We have one more class to do, and it's very similar to this pair class. So first I want to point out that when we create a pair, we can only create a pair of where the first and the second elements of the pair are of the same type, right? So we can say pair of integer, but we cannot say pair of integer and string, right? For example. So here we have another class which will allow us to do that, right? So in other words, here I want to have a class where each item in the pair, meaning the first and the second, could be of different types. So the first thing could be something of type T, and the second thing could be something of type U. So for example, I should be able to say here in the main method, different pair of string comma integer, string integer different pair equals new different pair, and put in a string and then an integer, right? So different pair of string and integer. And then I should be able to say string first equals string integer different pair dot get first, and Java will know that the get first method returns a string and not an integer. And when I say get second, Java will know that it returns an integer and not a string. So how can I make Java know all this? So here I can define, in the header of a class, I can define multiple formal type parameters, right? So in the pair class, I only defined a single formal type parameter, t. But here I can define really as many as I want. And so I can do t comma u. And so the first item in the pair is something of type t, where t could be any type. And the second item in the pair is u, is something of type u. And here our constructor, the first parameter is of type t, second is of type u, and we do this dot first equals first, this dot second equals second. And then here we have a copy constructor, same idea. We take a different pair of t comma u, original, and we copy from that original. Here we have a clone method. It returns a different pair of t comma u, and it does what you would expect it to do. Here is the of method. So this is, again, is a static method. So we have to define new type parameters for this method. Sorry, new formal type parameters for this method, and we call them R and S. We really could call them T and U, but then it would be confusing because they would be the same name as these T and U, even though they would have different. They would have a different definition, possibly, and so it's probably better to use a different names. So like here, R and S. So public static, and we're defining new formal type parameters for this particular method. For this particular static method, we're defining R and S, and it's going to return a different pair of R and S. And the first parameter is R, the second is S, and it returns a new different pair of first comma second. Okay, good. Set first takes something of type T and does this dot first equals first. Set second takes something of type U, not of type T, right? Not of type T, because the second field is of type U, not T. And get first returns something of type T. Get second returns something of type U, right? So okay, the toString method is the same as before. How about the equals method? So remember how we used in the pair class, we used unbounded wildcard when we talked about pair. So we said if O is a pair of unknown type. So for a different pair, we can't just put one unbounded wildcard, because different pair takes two things and has to have two things inside these angle brackets. So I put two question marks. And different pair of unknown and unknown other equals so we take O and we cast it to the different pair of unknown type. And then we do the same thing. We compare the first to see if they're equal, and we compare the second to see if they're equal. And if O is not an instance of different pair, then we return false. Now, how about copy from? So again, we're gonna use extends, but here we have to use it twice, right? So it's different pair of anything that extends T, and comma anything that extends U, right? So again, compare it with the pair class, right? So copy from this original one was pair of question mark extends T, and then in different pairs, different pair of question mark extends T, comma question mark extends U. And I'm actually sorry, just put in the simplified. what's going on here? All right, we'll just say this dot first equals other dot first. This dot second equals other dot second. Okay. And copy 2. So same idea, but here we use super, right? Here we're using super because this peer is the consumer, right? It's consuming things. We're copying from our peer to this other peer. So this other peer is consuming, right? So okay, so we'll just say other dot first equals this dot first, other dot second assigned this dot second, right? Okay, so now how can we use this different pair class? So we saw already we can say different pair of string comma integer, string integer different pair equals new different pair. So put in a string for the first thing and an integer for the second. Now, suppose we want to have a pair. Suppose we want to have an object of this class, so an object of the different pair class, but we want both parts to be strings. So can we do that? Yes, sure. We can say different pair of string comma string, string pair equals new different pair hello world, and that works just fine, right? So it just gives us, this class gives us more flexibility. It allows us to have a pair where the first thing is let's say a string and the second thing is an integer. It still doesn't prevent us from having a pair where both things are strings, but we do have to say different pair of string comma string. I cannot just say different pair of string. That would not compile. Okay, let's check. Right, so error, wrong number of type arguments. In other words, these things that I'm passing in here are type arguments, and it says required 2, and I only gave it 1. So I could, right? So I have to have 2 here. I have to put in 2, but they could really be the same, right? So don't think that just because, first is of type T and U is and second is of type U, don't think, oh, they can't be of the same type. In fact, T and U could potentially be of the same type. They just have the ability to be of different types, and that's what this other class offers to us. All right, so I believe that I've finished covering the topic of generics, and there's homework on generics, which I strongly encourage you to work on as soon as possible.